Uh, all right. So the next section, we do our deep dive into heat and fire. And these two topics became extremely pertinent this past year as we saw unprecedented heat. We saw things like collapsing saguaros around the Phoenix area. Um, we saw effects on our wildlife and effects on our vegetation as well, although not quite as extreme as in the inner cities. And we also had the first fire in the preserve in about 30 years, the Diamond Fire. Uh, so, these things have been on our mind. They've shifted some of the things that we've done this year, and some of the things that we will do in the future. So I'm going to introduce Mary Fastiggi. She is our restoration manager here at the Conservancy and Field Institute. And she is going to talk about fire ecology in the Sonoran Desert and kind of set the stage.
So everyone, it's nice to see you all today. It's been a very successful season, as Doug was mentioning, and we've been very busy. So what I'm going to do in this presentation is set the stage to talk about fire ecology in the Sonoran Desert. And then later on, we'll take a deeper dive into the work that we've been doing. So before we dive into wildfires in the Sonoran Desert and the preserve, I wanted to take a step back and think about a broader role of wildfires in ecosystems in general. So fire is an important component in many ecosystems, and some ecosystems actually depend on periodic fires, and those fires can promote plant and wildlife diversity in those systems. So I have two examples here. The first is for lodgepole pines in the Rocky Mountain areas. There can be pine cones that hang on to the trees for years. And naturally, fires in the system occur every about 80 to 300 years. And when a fire sweeps through, the pine cones have a lot of resin on them. And so that can melt off. And then the seeds are released and they're dispersed into a newly opened canopy. And so that's a system that's developed and has some really good fire adaptation. Another example, closer to where I grew up, is in the Midwest. There's these oak savannas in that area, and there's these beautiful, large bur oak trees that have extremely thick bark. I have a picture of it on the bottom left, and that protects them from fire. And they also have very deep root systems that can resprout after fire. And so fires actually keep the canopy open and prairie species can thrive in there. And so you have large, big trees with prairie species around them. But because of fire suppression, there are very few oak savannas left. So without the fire, the system shifts and I think in some cases it become farmland, in other cases it's become forests. But without that fire there, you don't really have the oak savannas. But what about in our desert, in the Sonoran Desert? There's a natural fire regime to every ecosystem, but it's not very well understood in the Sonoran Desert how fire has interacted with it. There are many clues, though, which point to fires being more rare, low intensity, and not very frequent. So what are some evidence for this? One is that we have very widely spaced plants out there. I think I have a pretty good picture here that doesn't have a lot of invasives in it. And so there wouldn't be a lot of fuel load in many seasons for there to be fires. And so maybe perhaps there might have been wet winters with some annual forbs that will come up that could increase the fuel load, but not every season and not very regularly. Another clue is that our keystone species in the desert, the saguaro, is not fire adapted. So saguaros are really slow growing. And so if fires were frequent, the species wouldn't have time to reproduce and establish. Also, saguaros don't have thick bark like the bur oak. If you think about them, they have this green flesh so that they can take in all the light everywhere. And they would be very vulnerable to fire. So this, along with other evidence, has really led to estimates of a fire frequency of maybe every 200 to 500 years and not that intense. And I did watch a presentation from a fire ecologist from Tonto National Forest who used context clues, and she was mentioning that it couldn't be every more than 30 years because it takes saguaros at least 30, 35 years before they're of reproductive age. So any frequenter than that, we wouldn't really see saguaros replaced on the landscape. But what we do know is that wildfires are becoming more frequent, especially since the 1980s. And reasons for that include, Doug was mentioning some of the big invasive plant species issues that we've been dealing with in the preserve and in the region. From left to right, I have photos of red brome, schismus, bufflegrass, fountain grass, and then Doug also mentioned the little globe flowered plant, which is stinknet. All of these plants increase the fuel load. They tend to spread between those natural spaces, those natural open spaces we had between native plants. They can also outcompete natives. And that combined with more human activity, there's so many more people living in the Sonoran Desert now. We can spread invasives. We can also increase ignitions. And with that combined together, we're definitely seeing that the fire regime is changing and we're seeing more rapid and more frequent fires. Right here, here's some invasive plants kind of between saguaros right there. You can see that both these landscapes have been impacted. The point I wanted to make on this slide is that this is a positive feedback loop. So once you have a fire and you have these grasses there, it starts shifting towards a grass-driven fire regime with more frequent fires. So the grasses can come back readily after the fire, but some of our important keystone species like the saguaro and other succulents like yuccas and our hedgehog cactuses and our buckhorns, they take longer to grow. And so you have fast-growing grasses competing with slow-growing cacti in an environment that's more likely to burn. And we've seen this really change within the preserve itself. So we've had 3 really major fires in the 1990s. We have the Ancala fire, which was down by Lost Dog in 1993, the Granite fire, which was about 2,000 acres in 1992. And if you actually go to Browns Ranch and you're hiking on the Browns Ranch Road Trail, if you look to the west, you'll see that the plant community actually looks quite different still after 30 plus years than it does if you look to the east. That road served as a fire break in that case. We also have the Rio fire, which it was much bigger than this. This is clipped to the preserve itself. My next slide will show how much bigger it was. And then we have the Diamond fire, which was almost 2,000 acres, 270 in the preserve that happened last year. Oh, and there's one little one in the corner there that I pointed out. And there's been more than that, but those were our major ones. So this is a broader view of recent wildfires in the region. Carrie Olson, who's a steward, for those who might not know him, he recently created this map for an upcoming display about fires at Pima Dynamite Trailhead. So you're kind of getting a bit of a preview of that. But you can see on this map that the 1995 Rio fire was much bigger than the clip that I had in the last slide. You can also see that he added the Wildcat fire, which happened this month. It's actually just getting towards containment, and that has impacted 14,402 acres. And we've had quite a bit of red brome this year. We had a wet, late winter rains, so that kind of helps to I'm sure, add fuel to the fire. And this doesn't even show some of the other major fires that we've had, like the Cave Creek Complex fires or the bush fires along 87. So there's fires quite everywhere. And so what do we do? What does the desert look like after fire? One thing that we have is actual research findings right here from the preserve. Kara Barron, who's now with the Desert Seed Resource Center, she conducted her master's thesis work on post-fire plant communities, and she used the preserve as one of her study sites. And at that time, we had a position called Biodiversity Fellow, and she was in that role as a student, and the Conservancy and stewards assisted with her work. And she studied all three of the major 1990s fires that we looked at in the preserve 20 plus years after them. And what she found was that plant communities were changed post-fire, even 20 plus years after recovery. And there were different plants that had different representations. So we had desert senna, catclaw acacia, brittlebush that had increased. And then others are succulent type species like hedgehogs, yucca had decreased. We also saw less penstemon, desert mistletoe, and saguaros, Wright's buckwheat. And overall, the pattern was that the slower growing desert adapted species like the cacti and the yuccas had decreased significantly, while some of the faster growing plants like brittlebush, which is a subshrub, that's what that one would be, had increased. So along with Kara's study, we also have a lot of information. Doug was talking about past projects we've done in restoration. And so we have this really rich set of data, research results, and the experience in restoration efforts across the preserve. We have detailed maps, evaluations of past work that's been done. We have seed lists and menus. We've done work with partners on seeding techniques. We really are participating in the innovative biocrust fieldwork that's done in partnership with NAU. And we've developed these partnerships with NAU and US Geological Survey and more. And so from all this work, we have published in peer-reviewed research papers to share with the restoration community. We also have a set of lessons learned that we're able to apply to our restoration work in the burn area. So we have now over 10 years worth of restoration research and experience to aid restoration recovery efforts in the Diamond Fire. And it's been really exciting to see that come together, even after something that we all wish didn't happen, but we're well positioned to work in that area. We also, as Doug was mentioning, have a very dedicated mapping, monitoring, and removal steward team. I did want to highlight that they ran the numbers this year, and so far they've surveyed 22,000 acres out of the 30,500 acres in the preserve, 30,580 acres in the preserve, which is basically all the land that's not just like an extreme slope that they could get to. And they've helped remove or identify to remove 2,700 acres of invasive grasses, which have now been treated over the past 8 years or so. We also have research papers on invasive plants. We're collaborating with the city of Scottsdale on removals, and we also serve on a lot of boards and working groups related to regional collaboration on invasive plants. And this is all really key to helping with wildfire prevention work. I also wanted to point out that, and I'm sure Jessie will touch on this too in their presentation, but we have research focused on habitat connectivity and animal movement. The gooseneck, which is the area of the preserve, the name for where the Diamond Fire happened. It's kind of between Rio Verde Drive and Tom's Thumb. It's a very sensitive area of the preserve because it's narrow and it's being impacted by development, and connects the northern part of the preserve with the southern part, and is a great corridor for animals. And now it's been impacted by the Diamond Fire. And we already knew that this was an important area. So our biodiversity teams had been collecting data out there with camera footage and wildlife movement studies like the tortoise study. And so now we'll be able to compare both before and after the fire, and that'll be really interesting. We're going to go more deeply into this after the break. So you'll hear more about our collaborations with City of Scottsdale, Maricopa County Parks and Rec, Sorrel High School, and more. But I did want to mention that we have had an incredibly collaborative team working together, and there's some really inspiring work going on. So we'll talk more about that later on, but for now, I'd like to turn it over to our biodiversity manager, Jessie Dwyer, who is going to talk more about tortoise movement and the impacts of heat. Thank you.
Thank you so much, Mary, for that introduction to fire ecology in the Sonoran Desert and for that nice introduction to me. So like Mary said, I'm Jessie Dwyer. I'm the biodiversity manager at the McDowell Sonoran Conservancy, and I'm joined today by a steward, Rob Hallagan, who is our tortoise project lead. And we could talk for hours about the impact of extreme heat and fire on many different species in the Sonoran Desert, but we really wanted to focus on the Sonoran Desert tortoise, partly because we have relevant research about this animal, but also because they're the quintessential desert species that's very well adapted to this environment. So understanding how they're impacted by heat and fire, I think, gives us an insight into what the future will look like. We're just go ahead and start with who is the Sonoran Desert tortoise. Sonoran Desert tortoises are reptiles. So they breathe air, they're vertebrates. Their skin is dry with scales or bony plates. In this instance, tortoises have both. They are cold-blooded animals, which means they regulate their body temperature with the environment. So they may move to the sun to get warmer and get away from the sun to get cooler. They also will lay soft eggs. Tortoises, just like saguaros, are very long-lived and slow-growing. So tortoises in the wild can live 30 to 50 years old, sometimes 60 to 70 years old, up to 80 or more in captivity. So they can be around on this earth for a very, very long time. But they don't just live for a long time. They also take a long time to become an adult. So at around 13 to 15 years is when a tortoise actually becomes an adult and is able to reproduce. And until then, they're more vulnerable to the environment. Their shell is softer, and it's kind of a hard life out there for the tortoises. But once they reach adulthood, they're really hardy. So they're very strong animals with very strong shell. And the only thing that can actually predate on a fully grown Sonoran Desert tortoise in this ecosystem is a mountain lion. So once they reach adulthood, they're pretty set. And they're just really incredibly well adapted to the desert environment. And we'll get into that in a second. They're also sensitive species that are protected by the state of Arizona. They are a sensitive Tier 1A conservation species of conservation concern through Arizona Game and Fish. Tortoises actually do not come with that type of equipment on their shell. That's something that we added on in order to track our tortoises. And we'll get into what that equipment is for a little bit later. But basically, we're tracking the movements of the tortoises, which allows us to know a lot more information about them. So very well adapted to the desert. So Sonoran Desert tortoises get most of their water through consuming plants. They also will drink water that collects on drinking rocks, but most of their water they will get through plants. They can recycle water in their bladder to use it for long periods of time. So they can sustain themselves over periods of drought. This is super helpful with unpredictable precipitation that occurs in the Sonoran Desert. And they can actually recycle that water for up to a year, which is very, very useful in the hot and dry desert. Tortoises can dig burrows, so they have really strong forearms and claws that they use to excavate the really hard desert dirt and earth. This allows them to escape extreme conditions like extreme heat or cold weather or even wildfires. They will also conserve their energy by going into what we call brumation, which is basically hibernation for reptiles, where they kind of go into a less active state and conserve their energy through the winter seasons or the winter months or the very, very hot time of year. Like I mentioned before, they're really hardy, strong animals, so they have really great deterring for predation, which helps them survive a very long time. And they also have some interesting reproductive strategies that help them out in a desert environment. Sonoran Desert tortoises have one clutch or a group of eggs per year, but they can actually vary the timing of when their eggs form and when they lay their eggs. And this allows them to wait for conditions that are favorable to egg production. And studies have found that it's not really body size that indicates how many eggs or the size of eggs, it's actually body condition. So the better condition the female is in, the more eggs and larger eggs the female will have, which leads to greater reproductive success. Also, interestingly, tortoises have what we call environmental sex determination, which means depending on the temperature of the eggs in the clutch after they're hatched, depends on whether they will be male or female later. There's ranges for male and female, but basically anything above 90 degrees Fahrenheit will be female, and then anything below will be male. And so depending on the conditions when these eggs are laid will determine what sex those tortoises are. And I really wanted to talk about the Sonoran desert tortoise specifically because of how well adapted it is to the desert. Many people might think that wildlife that is well adapted to the desert can handle things like climate change because they're really no problem with extreme heat, no problem with drought. They have all these adaptations that can help them handle those conditions. But recent research is thinking about how desert species actually might be more vulnerable to climate change than we think because they're often operating at their adaptive capacity limit. So they're already operating at their heat tolerance limit, at their drought tolerance limit. So as things continue to get dry and continue to get hotter, these species are near or at their ceiling of tolerance, which is very difficult to adapt to those conditions. Other studies have shown already that survival of Sonoran desert tortoises decreases with drought severity, especially tortoises that are really close to cities, which obviously impacts our Sonoran desert tortoises. And then in addition to that, a potential reduction in reproductive success if the heat or drought reduces body condition, that can reduce reproductive success. And also if temperatures continue to rise, that may also impact the environmental sex determination of the tortoises. So that's Sonoran desert tortoises and heat. What about fire? So tortoises have the ability to escape into burrows. So as far as direct harm of fire, they're able to go underground and hunker down as fires go through. But this really does depend on the intensity and the frequency of the fire. So like Mary said, historically, fires in the Sonoran desert were less intense, maybe not as hot because they didn't have the fuel load of the grasses. And so a tortoise could go underground and just wait out a fire, and it's not as big of a deal. And they're also less frequent. And so a fire goes through once in a blue moon, destroys some habitat, but eventually the desert regrows. But if it's coming through every 30 years or so, that doesn't give the saguaros a chance to come back. A lot of the native plants will be outcompeted by invasive grasses, and it just changes the ecosystem quite drastically. Particularly the one invasive grass that we're interested in as it pertains to tortoises is red brome. Studies have shown that tortoises that only eat red brome can die of malnutrition. So it's really important to have the native grasses that actually provide them nutrients and not just invasive grasses. And then of course, the invasive grasses take over a lot of their movement corridors. So that's one we're paying attention to. And then just another small fun thing is that the burrows that the tortoises create can be refuges for other species. There was a study in Australia that looked at wombat burrows and how all different types of species were using the burrows to escape the bushfire. And we have plenty of species that dig burrows in the Sonoran desert, but it's definitely likely that their constructing of these burrows is helping out not only themselves, but also other species in times of fire. And I want to pass it over to Rob to talk about our actual tortoise project and what we're doing in the Conservancy to study and protect the tortoises.
Thank you. So we began our movement study in 2021 during COVID. And as Melanie said before, it was one of the few things you could do outside in a group that was legal and allowable. I do have to say because this is a protected species, not only under state law, but under the Federal Endangered Species Act, all our work is licensed by Arizona Game and Fish. And our site leads had to go through both classroom and field training with game and fish biologists before we were allowed to handle the animals. And also we had to be permitted by City of Scottsdale to move off trail because these tortoises live in rocky, complex terrain throughout the preserve. This year at the moment, we're tracking 20 tortoises across 9 sites. We've had as many as 26. And the purpose of the study is to evaluate the impact of urban stressors. And the urban stressors we're looking at are the edge effect, that is development that leads up to the boundary wire of the preserve, as well as motor vehicle traffic, paving of roads, and trail use as our visitor load increases in the preserve. And doing all this, not only are we doing movement studies, but we're filling knowledge gaps in habitat and behavior. The Sonoran desert tortoise is not as well documented as the Mojave tortoise up in the Northwest, which is a true endangered species and therefore has a lot of academic and government interest. We take all this information, and the point is to inform city management of the preserve. We can present the facts, and the city can decide their action. And the last point, just the overview of the project, is I do have to say as Doug mentioned, we're funded by a heritage grant through Arizona Game and Fish for the first 3 years. And the program was successful enough that it was extended into this 4th year with City of Scottsdale picking up the tab because of the importance of the information we're able to get. So next one, please. Oh, there we go. We've got 59 marked tortoises in the study. And these are tortoises we've collected, we've weighed, we've measured, we've assessed, we've documented their locations. 20 of them have transmitters on them. And that's simply because you don't need to transmit every single tortoise. If I've got a site and it has 8 tortoises in there, a mix of male and female, 1 or 2 is good enough for the site without having to spend the money to transmit every tortoise. And then we have numerous, I'm going to say upwards of 70 other incidental observations of people in the preserve have sent us all the way from Lost Dog up to Granite Mountain as they encounter tortoises on the trail and send me the information. This is the good news. The tortoise population in the preserve appears healthy. And we measure a healthy population by the male-female mix, the age distribution, the absence of disease called upper respiratory tract infection, which is moving from the north to the south, has not reached the Tonto or the preserve yet. And something we call body condition score. Jessie mentioned the body condition score on the females for their reproductive strategies. Body condition score looks at the hydration, the stored fat, the condition of the skin, the nares, the mouth, the eyes, and so far it's all thumbs up on the tortoises that we have collected. One of our observations in the movement, and we're not going to do a whole movement study presentation here, is they've self-selected a microhabitat, I'll call it. And that microhabitat can be 100 to 200 yards, and they'll live their lives there. They're born there, they live there, and they die there. But what they are done is they're extraordinarily intimate with the terrain. They know the plants, they know where the water collects, they have summer burrows, they have winter burrows, and they exhibit similar movement patterns every year within this microhabitat. And some tortoises, the males, have gone on what we'll call walkabouts. And because we're getting a snapshot of their 60 or 70-year life, maybe they do this all the time and we're just seeing it. And we've had a couple that have done what I'm going to call relocations. It's interesting, the picture being shown right there is a hatchling. We have found hatchlings in small. That's the size they come out of the egg. And that particular tortoise still had its egg tooth and an egg yolk attachment to it when it was found. When they're hatched, they'll quickly skitter into shelter because they're extremely vulnerable to birds, and particularly their raven treats. Next one, please. So we, along with doing the movement tracking study, we've placed burrow cameras at several locations. And from that, we've been able to observe behaviors uninterrupted or uninfluenced by humans, by us being there. That video on the left is courtship behavior between a male and a female. That's a very characteristic head bobbing they go through, and the top center picture was the same. Two tortoises visiting each other in a burrow. They went through a whole head bobbing ritual there and then checked out and went on their way. Nighttime, particularly now, it's 105 degrees. They will stay in shade in the burrow to regulate their temperature, but will come out in the evening to get a little food. And if it rains any month of the year, they'll come out for rain. The need for water is so desperate. The tortoise on the far right there is mining. That is, that's a female, and what she's doing is she's eating the dirt and rock. And the purpose of that is to get the trace minerals she needs that are not available through plants. And so they'll do that, that mining behavior. Next up. The burrow cams have captured over 40 species that we've counted using or visiting tortoise burrows. There's some interesting ones there. We see a lot of skunks. We've seen all three species of skunks, hooded, striped, and spotted. Roadrunner with a lizard in its beak, a gray fox checking out the burrow, a mountain lion, various snakes. We've cataloged three species of rattlesnake, the western diamondbacks, of course, blacktail and tiger rattlesnakes. That, I think, is a western patch nose. And to Jessie's point about burrows as a refuge, other animals in that habitat know these are tortoise burrows, and they visit them. They visit them regularly. And yes, they could serve as shelter. In particular, I have Juan Fogel's feet there. Not all burrows are small, and an animal could easily find refuge in there. So let's talk about a couple of tortoise stories. Melanie kind of previewed that these are not going to be happy stories, but they're stories I need to tell. The first one is tortoise 709. 709 was found by one of our teams on their way home from a telemetry event on 128th Street in the construction area there, just north of Tom's Thumb, where Story Rock is being built. And that's 709 curbside out on 128th. Now, they stopped. Normally, if you would find a tortoise on a roadside, the correct thing to do is to pick it up gently, keep it low to the ground, and move it the direction it was going, right? Help it across that road and let it go. In this case, it would have meant releasing the tortoise into an active bladed construction site on either side of the road. So we called Arizona Game and Fish, the tortoise program at Arizona Game and Fish. Outside the preserve, we don't have any authority or permissions that any other Arizona resident doesn't have. We have nothing special outside the preserve. Our permit's only for there. And their direction to us was if we could safely move that tortoise out of the construction zone and into the preserve. So we took the opportunity, since we had the equipment with us, to go ahead and what we say is process that tortoise, weigh it, measure it, evaluate it, install a transmitter, mark it, and install a GPS unit. And that tortoise was moved into just inside the preserve boundary there at Tom's Thumb, but definitely out of the construction zone. Next up. So that tortoise moved from the vicinity of the Tom's Thumb gate up into the foothills there and lived there for a year. Unfortunately, that tortoise was maladapted to that region. It started healthy. It went through a year of decline. And when it was in decline, it was visible from the trail. And a visitor decided that tortoise was being tortured because it had this equipment on it. And I'll assure you they're not tortured because they have an equipment. And that visitor took that tortoise, stole it, removed it from the preserve, and dropped it at the exotic animal hospital in Cave Creek. Okay, there's several things wrong with this. One, it's a violation of state and federal law to steal tortoises. It's extremely stressful to the tortoise. You got to remember, this tortoise then would have been picked up, carried out, put in a car, driven over to Cave Creek, dropped at a hospital, and that's the picture in the middle if it's on the exam table at the hospital. The person left. The hospital realized that they had an illegally taken tortoise. They told Game and Fish. Game and Fish knew it was one of ours. Connections were made, and we got that tortoise back, and we re-released him there on the right into his known habitat. However, sadly, that tortoise did not survive. It continued to become more dehydrated, more emaciated, and did pass away through a combination of, we think, stressors. I'm not a game biologist, so I can't swear to you what happened, but that tortoise lived an unfortunate last year of its life because of these stressors. So let's look at another tortoise story. Not quite as sad. This is 210. 210 was a very old male. We did have a senior retired biologist from Game and Fish with us, and he estimated that tortoise is easily 70 years old. And we captured him, processed him, hydrated him, and followed that tortoise for 2 years. And as he made his movements around the Tom Thumb area, and let's look at those movements that he was making. So this is a wide-ranging tortoise. If he was 70 years old, that meant he was born in 1955, right? 1950. Nothing was there. All those houses you see on the map, the roads, none of that was there. This was his life. And this was his movement area. And since then, in the 90s with the Rio fire, and then recently with the Diamond fire, and with the construction, which is not totally shown on this map, of Sereno Canyon on one side and Story Rock on the other side, this tortoise lost his home range where he had been living for many, many years. He eventually left his home and went into the county park on the right there, and then on the left, spent a winter in the gooseneck, and we tracked him, let him have his life. We tracked him, and then we lost him. And he turned up on the far left there on Troon Mountain in somebody's backyard. Let's show that. And we only found this out because it was posted on social media, and of a gentleman doing the right thing. He found our tortoise on the highway and he moved it off the roadway into the brush on the side. Tortoise continued to move, got stuck in a backyard fence. And again, that resident called the Arizona Game and Fish, which is the right thing to do. They knew it was one of ours. They got a hold of us. I went out there and collected it. And we brought it back to his home territory in the preserve and released him. And that's a field of owl clover, not red brome. He, however, also was never happy going back. He had left for some reason. And we brought him back at Game and Fish direction. And he also relocated into the foothills of Tom's Thumb there. And he also expired, most likely of old age, peacefully of old age. But that was a tortoise that over 70 years fulfilled his biological imperative. He had girlfriends probably all over the town there. And but the last summer, brutally hot. He did go through a relocation, even though as gentle as we could be. And there was a consequence. So Jessie, talk about the consequences.
Yeah, thank you, Rob. So one of the things that we're kind of talking about here with all of these different factors that are contributing potentially to these tortoises passing away, and we're thinking about these as compounding stressors. So both of these tortoises had interaction with urbanization. 709 on the active construction sites. 210 actually had 2 years where he went into the construction zone, and then the large traveling he did into the gooseneck area, and finally the housing development. So these are tortoises that are interacting intimately with rapid urbanization. So we're seeing potential effects of habitat loss on these long-lived species. On top of that, there are tortoises that are being removed from the wild, which can be really detrimental to their health for the reasons that Rob mentioned, and also disease spread as well, which is why it's one of the reasons why it's illegal to release tortoises in the wild as well. And then on top of that, last summer, we had one of the hottest summers on record. I think last year was the hottest year on record in the last 2,000 years. And particularly that month of July, where we had 30 days of consecutive temperatures over 110, was very difficult for someone like this tortoise, 210, who's older, already stressed out in some other way. It's kind of a compounding stressor. With 709, we also found that it didn't seem like he really had established burrows. So like Rob was mentioning, some of our tortoises, they have their summer burrow, their winter burrow, their drinking rock. They go to it every year. They have a very similar movement pattern. And 709 just did not have an established microhabitat. And so when things like a super hot summer hits, or a removal from the wild, it just really adds to that stress and that impact. And then on top of that, we had a wildfire come through again in that gooseneck area, which we at least have one tortoise documented moving through that area and using it as a travel corridor. And then on top of that, 709 had some dehydration issues and poor health, and 210 had some old age. So we're thinking about this as, large fires or increased heat might be something that some of the tortoise population can handle, but tortoises that are particularly vulnerable are ones that have these compounding stressors and urban stressors. So overall, what is the impact of heat and fire on tortoises? So there's indirect and direct harm. So a fire comes through, hopefully tortoises can burrow underground, but those fires can reduce native quality habitat, increase invasive species, change the regime in something that tortoises may not be adapted for. We have those compounding stressors that are added on top of all the other factors and all the other threats that tortoises are facing. And on top of that, they might be at their limit of adaptive capacity. So already operating at their heat tolerance, already operating at their drought tolerance. So added things like more frequent and severe wildfires or increased temperatures or prolonged drought can be detrimental to the tortoise population down the line. And then we have a potential future decline in reproductive success as we have more years of drought and increased temperatures that may affect the sex determination, the sex ratio of tortoise hatchlings, as well as the body condition of our tortoises. So that's a lot, but it's not, all hope is not lost. There are many things that we can do, and many things that we already are doing to help mitigate these issues. One of those would be managing invasive grasses. So that helps reduce fire, which also helps increase the amount of native habitat that tortoises have available for resource availability and for traveling. Restoring the burned areas. So like we mentioned, if fires are happening every 30 years, the saguaros cannot keep up. So the work that we do to add saguaros to establish in those burned areas can help that native habitat grow back. Protecting and conserving open space. So as urbanization creeps in and as people increase visitation, we'll want to make sure we have protected open space for these long-lived species to continue traveling around their home ranges. Any sort of reduction in compounding stressors can be really helpful. So our education initiatives to try to explain to people not to remove tortoises from the preserve is a really good example of reducing a compounding stressor, so that a tortoise might maybe be experiencing urbanization and heat, but maybe not also removal from the preserve. So working to reduce those compounding stressors so that tortoises can handle the increased stress of the environment. And of course, continue studying the Sonoran as a tortoise. So there's still a lot we don't understand. We do have 4 years of movement data and some really incredible data we've got from the burrow cameras and just from being out there with the tortoises. But like I mentioned before, these are really long-lived species. So every year is just a snapshot of their lives. And we only know what we have on the data we've collected. And so we really want to see what happens over long, long periods of time and how these tortoises react to rapid environmental change. And that's all. Big thank you to all of the citizen scientists on the tortoise team and all of our partners that help with this project. And thank you, Rob.
So one of my jobs on the symposium today is to go through keep track of the chat log and bring some questions forward. Here in the introduction, we just got a couple of things. One, I want to say Lori Shriver from the U.S. Geological Survey is the manager of RestoreNet, has been kind enough to put her email and the website for RestoreNet into the chat log. So during the break, you might want to, copy, cut, paste that, and at some other time, look at the website and see what all is going on in RestoreNet. And we did get one question from Sylvie on how do you determine the age of tortoises? I'll take a try at that. It's an art and a science. Part of the science is we measure the carapace length. The carapace is the top shell of a tortoise. And by looking at the length of that carapace, we put them into groups of juveniles, subadults, and adults, because the tortoise will continue to grow through its life. Also, when sexual characteristics appear for the first time, the males will form testosterone glands underneath their chins, and their plastern, which is the undershell, will also indent for mating purposes so they can mate with the females. And that's the science part. The art is you'll look at an awful lot of tortoises and you compare them with tortoises that are in captivity or have been in captivity, and you have a known birth year or age of that tortoise. Did I get it right, Jessie?
Yeah, and that's a good mention about the captivity is, tortoises will grow faster if they have a lot of resources. So sometimes the tortoises in captivity look a bit different than the tortoises in the wild do. But really we can tell age in those age classes. And then once we get to adulthood, it can be very, very difficult to tell. But some of the things that we're looking for is the wear and tear on a tortoise. Does it seem like this tortoise has been out for 1 decade, or is it really kind of worn and torn like our 210 was? And that can give us an indication of the age. But really, a lot of it is just estimations and experience being around tortoises of different age classes. But it's not really like tree rings where you can actually definitively tell the exact age of tortoises.